This Chalk Talk has it all: EV charging, telecom, power distribution, industrial battery chargers, brake control, test and measurement systems, and more. Yes, more. And what in the world could we be talking about? And how long will this Chalk Talk be? Any guesses? All right, I'll tell you. Solid state isolators are the name of the game for this here Chalk Talk, and all the cool ways you can use them. Hi, I'm Amelia Dalton, host of Chalk Talk. In this episode of Chalk Talk, Jaidev Dalvi from Infineon and I explore the host of benefits that Infineon's solid state isolators can bring to your next design. We also investigate the mechanics of solid state isolators and how they differentiate from mechanical relays, and how you can get started using Infineon solid state isolators. And before we get started, don't forget to click that link. There you can find even more information about this topic from Infineon. Hi, Jaidev. Thank you so much for joining me.
Hi, Amelia. Thank you so much for having me.
Absolutely. Okay, so we are talking all about solid state isolators today. But before we dig into the details of the applications in this space, Jaidev, what kind of products are we talking about for these solutions?
As you know, we launched our coreless transformer based solid state isolators at the popular Power Electronics Exposition APEC last year and have had a great response so far. We also have some great products on our roadmap releasing next year. Let me dive into the released products. Talking about the products, we have five variants available right now. On the left, you can see two variants in a standard DSO8 300 mil 8-pin package. Let's begin with the ISSI 20R02H variant, which has a dynamic Miller clamp and either over temperature protection or over current protection. Now, let's talk about the 20R03H variant, which is on the bottom left, where you have both overcurrent protection and over temperature protection, but without a Miller clamp. Now, the variants on the left that we just discussed are for standard turn on time with a typical output current of 175 microamps. We also have three variants shown here on the right, which have a fast turn on capability with high output current of 400 milliamps. Let's begin with ISSI 20R11H on the top, which is also in a standard DSO8 300 mil 8-pin package. It has a pin for a buffer cap, which accumulates energy on the output side to enable fast turn on. It also has another pin for protection, which you could use either for overcurrent or over temperature protection, similar to the 20R02H variant we previously discussed. The last two variants on the bottom right are ISSI 30R11H or 30R12H. These are both in a DSO 16 300 mil 16-pin package, so they have all the features you could think of: fast turn on time, dynamic Miller clamp, over temperature protection, and overcurrent protection. The main difference between the 30R11H and 30R12H is the way it does temperature sensing. The 30R12 can sense temperature through the diodes integrated in our cool MOSFETs, which could be very fast. Or in 311H, you could do it through a PTC that you need to design near the shunts or the MOSFETs. The table at the bottom summarizes what we just went through. Another thing to mention is that all our parts have reinforced isolation with 5.7 kilovolt RMS isolation voltage and operate with an input voltage range of 2.85 to 3.5 volts with an output voltage of 17 volts at 3.3 volts input.
Okay, so walk me through how an Infineon SSI would be used in an application.
Sure. If you look here, we have our SSI in the diagram, which receives an input signal from a microcontroller or whatever control system you have in your application. When the SSI receives the input signal, it turns on the switch at its output, which in turn connects the load to the load supply by closing the loop. The load could be a MOSFET or IGBT, and in an AC configuration, which would be common source or DC. You can also parallel multiple switches for higher currents, both in AC and DC configuration. Our SSI also has integrated overcurrent and overtemperature protection features, which help protect the load by turning off the switch when a fault occurs.
So, Jaidev, what kind of applications would Infineon SSIs be a good fit for?
As we just saw, solid state isolator combined with a MOSFET or IGBT acts as a solid state relay that switches the load supply on or off. Believe it or not, relays are everywhere, from telecom to smart homes. Our solid state isolator products are most suitable for applications where the output load power is less than 3.5 kilowatt. This can be found in solid state relay modules for industrial and building automation and control applications, battery management systems in applications like server battery backup units, photovoltaic inverters, and so many more applications, some of which are shown right here.
All right, so Jaidev, let's walk through these applications.
Okay, on this slide, we are focusing on the applications. When you combine an SSI with a MOSFET or IGBT, you essentially create a high performance solid state relay. What makes it stand out is the built in overcurrent and overtemperature protection, which means you don't need external fuses for every channel. That simplifies the design, saves space, and reduces cost. This is exactly what's needed in DIN rail, hockey puck, and panel mount solid state relays used across industrial and building automation. Another important point here is the ability to shut down a single channel in case of a fault, which improves overall system reliability. These relays handle random switching loads up to 230 volts AC and 16 amps, covering a wide range of real world applications.
So, Jaidev, what about the solar applications you mentioned? Can we dig a little deeper into this area?
Sure, this slide highlights photovoltaic microinverters, where solid state isolators can be used as a panel disconnector. In solar, the priority is safety, reliability, and lifetime performance. With our solid state isolator, you get fault protection that reacts in under a microsecond. So the system is immediately safeguarded if there's an overcurrent or overheating event. And since the protection is integrated, there's no need for external fuses, which lowers cost and simplifies the design. The typical voltage and current for panel level electronics is 80 volts and 16 amps, which our SSI can work with. Just as important, being solid state means no moving parts, no wear out, and much longer lifetime compared to mechanical relays, which is critical when solar installations are expected to operate for decades without failure. This also reduces upkeep costs.
Okay, and I also think you mentioned HVAC controllers as well.
Right. In commercial HVAC controllers, digital output modules drive loads like thermostats, fans, and solenoid valves. The challenge with traditional mechanical relays is heat, size, and long term wear. By using SSI, you solve those issues with low power dissipation, integrated protection, and no mechanical parts to fail. This slide points out these designs cover loads from 24 volts AC all the way to 230 volts AC up to 4 amps, which takes care of most HVAC use cases. For building automation OEMs, the result is smaller, cooler, and more reliable controllers that needs less maintenance while keeping energy efficiency high across large installations. Moving on to the next application, this one is all about uninterruptible power supplies, popularly known as UPS. In a line interactive UPS, you need a static switch that can safely transfer between line power and battery backup. What you see here is SSI filling that role. The benefits called out are fast turn on, fast turn off, low power dissipation, and fault protection, which means that when the UPS switches, it happens seamlessly without risk of downturn. And since it's solid state, the switch is both quieter and far more reliable than a mechanical relay. The target range here is zero point 0.5 to 5 kilowatts, which covers everything from small office UPS systems to mid range units used in server rooms and networking racks.
So, Jaidev, what about the battery disconnect you mentioned earlier?
Exactly. This slide shows SSI in battery disconnect applications. Think about systems like battery management, energy storage, power tools, or even light EVs. In all of those cases, you need a safe, reliable way to disconnect the battery, especially when voltages are above 80 volts. SSI delivers galvanic isolation plus a very fast response. So, in the event of a fault, the disconnect happens almost instantly. Another use case here is input isolation in soft start circuits, which ensures batteries connect in a controlled way without sudden inrush. The net result is safer, more compact systems without the need for bulky mechanical relays or extra protection circuitry. The next slide moves from battery disconnect to battery protection. Here, the SSI plus switch is placed in the charging and discharging paths, providing both current limiting and fault protection. That's especially valuable in server battery backup units and data center BMS systems, where uptime is critical and failure is costly. The SSI simplifies the design by integrating protections and eliminating the need for extra components, while also reducing power dissipation. The system here shows common drain solution for the charge discharge FETs. For system designers, the real win here is improved reliability. The battery is not only safely connected and disconnected, but actively protected during operation, ensuring the system runs longer and with fewer risks of failure.
So, Jaidev, these solutions can also be used in industrial battery chargers as well, right?
Yes, that's correct. Industrial battery chargers, like those used in forklifts or e mobility fleets, need to handle high currents safely and efficiently. The solid state isolator based relay can support the typical voltage and current used in the application up to 48 volts DC and 45 amps, making it a strong fit. It also protects against short circuits and reverse polarity, which are common in industrial environments. Another key benefit is you don't need an additional output power supply, which keeps the design more compact and reduces cost. For manufacturers, this means delivering a charger that's not only smaller and more reliable, but also easy to produce and maintain in demanding industrial settings. The next application we'll talk about is laboratory power supplies. In laboratory power supplies, the need is precise, reliable switching of loads, often at very high currents. This slide shows how SSI makes that possible. The system can handle up to 10 volts at 300 amps while protecting against external short circuits. That's impressive because it shows just how scalable our solid state isolator is, supporting low voltage but extremely high current scenarios. Another plus is that SSI eliminates the need for a separate output power supply, which saves space and simplifies design. For labs, this translates into power supplies that are safer, more compact, and capable of handling extreme current loads without relying on bulky, failure prone mechanical relays.
So, Jaidev, what about smart home applications? I would imagine this solution would be a great fit there as well.
Definitely. In fact, this slide highlights smart plugs and outlets. In these designs, space is tight and reliability is key. An SSI relay lets you safely control household appliances like lamps, fans, or coffee makers with built in overcurrent and overtemperature protection. The ratings up to 230 volts AC and 16 amps cover the majority of household devices. Because it's solid state, you avoid relay chatter and wear, which means longer product life and a better end user experience. For smart home OEMs, SSI is a way to deliver compact, reliable products that customers can depend on for years, even with daily switching cycles.
So I think you also mentioned telecom applications as well.
Yes, telecom is another strong application. Power delivery in telecom infrastructure requires extremely reliable switching, and that's what SSI provides. The slide shows uses like bus voltage control and relay switches for SMPS or battery modules. The need in these telecom systems is up to 48 volts DC and 20 amps, which our Infineon SSI based relays can handle. The built in protection and fast fault response means fewer failures and better uptime. In an industry where network downtime is unacceptable, having a reliable solid state solution that responds in microseconds to faults is a real advantage over traditional electromechanical relays.
Absolutely. So, Jaidev, what about other industrial applications?
Yeah, let's talk about the industrial applications. On this slide, we are looking at PLC IO modules and automation systems. These modules control things like motors, heaters, and actuators, which means they need to reliably switch AC loads up to 230 volts and 5 amps. With SSI, you get faster switching, built in protection, and reduced size compared to traditional relays. That makes it easier for OEMs to design more compact digital I/O cards. For robotics and factory automation, the benefits are clear: fewer failures, lower maintenance, and systems that are both safer and more efficient. It's a straightforward way to modernize industrial input output while keeping performance strong.
Sure. So, Jaidev, what about power distribution units? Those applications would be a good fit here as well, right?
Absolutely, Amelia. PDUs need to manage power across multiple outlets. And typically that means adding fuses for each channel. But this slide shows how our Infineon solid state isolator eliminates the need for those fuses since fault protection is built right in. That makes the design smaller, safer, and easier to scale. The relays handle 230 volts AC at 16 amps, which is perfect for both industrial PDUs and data center rack power distribution. And in data centers, space, efficiency, and reliability are critical. With SSI, PDUs can deliver all three while also simplifying manufacturing and reducing long term operating costs.
Sure. So, Jaidev, I think you also mentioned EV charging as well.
Yes, and this slide highlights exactly that: AC wall mounted EV chargers. Your SSI relays are used to connect the AC supply to the car's onboard charger, but only after the initial handshake between the charger and the vehicle is complete. This ensures safe and controlled power delivery. The solution scales up to 22 kilowatt, which covers a lot of residential and commercial wall chargers. The real advantage here is long term reliability. No mechanical wear, no contact bounce, just consistent, fast switching. For EV charging, where safety and uptime are crucial, SSI is a great way to make the charging process safer and more dependable. The next application is about brake control in industrial drives, a critical safety function in systems like elevators, cranes, and automated machinery. Our Infineon solid state isolator based relay provides galvanic isolation and very fast switching, which means brakes engage and disengage precisely when needed. The ratings are typically 24 volts DC or 230 volts AC at around 2 amps in this application. Because there are no moving parts, you avoid mechanical wear and improve system longevity. In safety critical applications, reliability is everything. And our Infineon SSI gives manufacturers a way to deliver precise, consistent brake control without compromising on safety or durability.
So I believe you also mentioned test and measurement systems as well. So can we also chat about those designs?
Sure. This slide highlights automated test equipment where our Infineon solid state isolators could be used to switch individual channels for pin or IC testing. The value here is precise, repeatable switching at voltages up to 60 volts and about 1 amp with very fast response times. By integrating protection features, SSI helps simplify tester design and reduces the risk of damaging expensive devices under test. Another advantage is compactness. These systems often pack hundreds of channels into tight spaces, and our Infineon solid state isolator helps make that possible. For semiconductor testing in particular, it's a way to improve uptime and throughput while keeping test hardware more reliable.
That makes sense. So what about connected and smart lighting? Can we also take a closer look at these kinds of applications?
Sure, definitely. This slide shows the role of SSI in smart and connected lighting. In these applications, you often want to be able to shut down a single channel in case of a failure without taking the entire system offline. Our Infineon solid state isolator enables that while also providing built in protection against faults. The ratings here are at 230 volts AC or 120 volts DC at about 1 amp, which covers typical lighting systems. Because it's solid state, you also get quieter and more reliable switching, which is ideal for smart building and IoT environments. Overall, it makes lighting systems safer, more compact, and easier to manage at scale.
Okay, so Jaidev, this has been a lot to take in today. Can you recap your main points for me?
Sure can. The takeaway from all of these applications is that Infineon's solid state isolators provide a modern solid state relay solution. You get faster and more reliable switching, integrated fault protection, and a compact design that lowers cost and simplifies engineering. When combined with our broad switch portfolio, these Infineon solid state isolators fit into a huge range of use cases, from industrial automation to EV charging, AI server battery backup units, battery disconnect, test equipment, telecom, solar, UPS, and even smart home products. The result is safer, more efficient systems that are easier for engineers to design and maintain. In short, SSI brings the reliability and performance needed to replace traditional relays across the board.
Fantastic. Well, Jaidev, I think that's all I have time for today. Thank you so much for joining me.
Thank you.
And before we go, you didn't forget to click that link, did you? There you can find even more information about this topic from Infineon. For Chalk Talks, I'm Amelia Dalton from eejournal.com. For more Chalk Talks, head on over to the Chalk Talks section of EE Journal. You can't miss it, it's right across the top. Or head on over to YouTube, youtube.com/EE Journal.